Olá pessoal, vamos falar agora de Serverless e Event-driven. Bora lá. Então, o evento do AWS Reinvent teve um foco muito interessante aqui em disseminar ali os produtos já existentes da AWS para Serverless e para Event-driven. Acho que né, o foco principal não foi lançamento de novos produtos, né? Mas sim de tentar promover uma mudança cultural, um mindset ali de que o mundo é assíncrono, a gente reflete nos nossos sistemas aquilo que acontece no mundo. Então, teve muitos palestrantes ali falando que tudo que você puder fazer preferencialmente assíncrono, faça assíncrono. Só faça síncrono se for estritamente necessário, mas né, parta do princípio ali que tudo pode ser assíncrono. Teve muita divulgação ali dos serviços serverless com a filosofia de se utilizar primeiro o que é serverless e depois avaliar possíveis mudanças. Tem uma palestra bacana aqui de um dos principal engineers da AWS sobre arquiteturas orientadas a evento. A gente vai conferir a diferença aqui dos conceitos de orquestração e coreografia, como que a gente utiliza na prática cada um desses conceitos, quais são as ferramentas apropriadas ali, o AWS Step Function, Event Bridge, por aí fora. E tem um case muito interessante do Serverless Presso, que é um café, uma cafeteria ali que tinha lá dentro do evento, né? Então, você chegava lá para pedir um café, tem um painel com QR Code, você escaneia, escolhe sua bebida, que era um cappuccino, por exemplo, faz o pedido, esse pedido cai num painel com código, e aí quando ficar pronto eles chamam, e aí você vai lá e pega a sua bebida. E eles fizeram todo esse sistema utilizando o que é mais recomendado ali pela AWS, como uma arquitetura serverless eficiente, utilizando todos os recursos da melhor maneira possível. Então a gente vai mostrar aqui mais no detalhe qual foi o desafio, o que precisaria ser feito, qual foi a solução que a AWS implementou e o custo final dessa infraestrutura também. Bora lá. Então vamos começar aqui por um trecho da palestra do Werner Vogels, The World is Asynchronous. É bem interessante, vale a pena conferir.
Have you ever thought about the world? All of its goings on? How chaotic it might be? You probably see it when you get your coffee, or when you turn on your laptop, or when you detangle all of the wires underneath your desk.
Of course. I often say the world is asynchronous.
Now imagine a world that is ordered, synchronized, one by one. Would you like to see that world?
Nope.
Where's your sense of adventure? Look, if you take the blue pill, our story ends here and this conversation never happened. If you take the red pill, I'll show you a more ordered world, one that is synchronous.
What about the yellow one?
Oh, that's just a jelly bean. Banana. All I'm doing is offering a simulation.
Here you go.
Thank you. I'll need a minute.
Oh, take your time.
Burger and fries?
One at a time, please, sir.
Burger?
Anything else?
Fries?
Excellent.
This place is crazy.
No, this place is synchronous.
Well, this place sucks. And how did you get that so fast?
It's not how, but where. Shall we? It's for you.
Please welcome the Vice President and Chief Technology Officer of Amazon.com, Dr. Werner Vogels.
Hello, Vegas. I really should have taken the blue pill, to be honest. Yeah. There's absolutely nothing that is synchronous in this world. And if it is, we really wouldn't like it. And think about those things when you're building your computer systems. And actually, I think the example there is actually really good. What I've really learned is that if you really want to build good computer systems, you have to look at the real world. And what I've observed is that the real world is asynchronous. It's not deterministic. There's so many events happening around you, trillions of events, all the time. Yet we seem to function pretty good in an environment that is not so terribly controlled. And so when I think about asynchrony, what I think is that it's similar to that the world always keeps turning. No matter what happens in the world, our planet keeps turning. And so, if I think about asynchrony, it is that we should make progress under all circumstances. No matter what happens in our world, in our digital world, we should still be able to make progress under all circumstances. And actually, if I think back about now 16 years, when we launched S3, we had a whole series of distributed systems principles where we built S3 against. And one of them is asynchrony. We wanted to make sure that the system would make progress under all circumstances, no matter what the load, no matter what is failing, no matter what new functionality we are introducing in the system, it should always make progress. Now, of course, a lot of it is synchrony, because we enjoy synchrony, because it seems so much easier. The things we really care about are latency and throughput. And in this particular case, in classic synchrony, as you can see, throughput is 1. And latency, if that one worker has to go through the whole chain of everything that it needs to do, and fry one fry by one fry, that was actually pretty amazing. Then you see that latency as well as throughput will suffer. Now, of course, you can add more parallelism to it. You have multiple workers. But they still actually they're probably blocked on a shared resource, which is the fryer. And as such, maybe it looks like throughput will improve, but latency will definitely suffer. So getting closer to the real world is asynchronous. Then you'll have one or more servers, and all they do is take orders. And then they write these orders on a slip and put it on a rail for the chefs to pick up. And you have multiple chefs. Each of them are at a station. And so they all see the order coming by, and if they need to work on it, they pick it up. And you can have these things happen in parallel behind the scenes for you. It is parallelism, but without blocking on any of the shared resources. Now, if you really want to improve latency and throughput, you can have some of these stations introducing actually additional workers. So there's actually a system in the, I think, 90s that Matt Wells developed, which was called event-driven architectures, where basically, you have all the benefits of an event-driven architecture, but you have controlled parallelism in each of those individual units to make sure that they're not blocked in any resources. Again, coming back to the design principles of S3, we took that into account. Yeah? We really wanted to make sure that there was controlled concurrency and controlled parallelism. Yeah, controlled concurrency really means that you have to think about where are the blocking resources that you have in mind. Now, sometimes the world looks synchronous. And one of those examples is bird memorations. They look so beautiful. They are absolutely amazing and mesmerizing. And it looks like there is a centralized controller that tells all these starlings where to go and what to do. Our ancestors actually thought that there was telepathy in the birds that kept them going. But nothing is more true. This is not a synchronous system, because it's nature, and nature is asynchronous. So all the actions that the bird takes are based on local observations. What it does, it has 3, maybe 4 objectives. One of them, it wants to stow claves to its mates, but it doesn't want to fly into them, and it would like to avoid predators. And so what you see there is that if the other birds get further away, you accelerate. If you get too close to the other birds, you switch direction. And if you are sort of in a nice spot, you make sure that your speed is like the speed of the other birds around it. And this behavior of attraction and repulsion looks like a spring. Now, in the 60s, 70s, there was some fundamental thinking, what's called systems thinking. Donatella Meadows is one of those famous authors that's written much of these books about systems thinking. And she already came up with the notion of positive and negative feedback loops. And what you see here with these birds are positive and negative feedback loops. They continuously move back and forth. Actually, in my academic days, I built simulations to do this. Yeah, you have X, Y, and Z axes, and which basically result to pitch, yaw, and roll. So what you see here is that it's purely driven by local decision making. The bird is completely autonomous, even though the overall system looks like it's working in synchrony, but it's not. This is a pure asynchronous system. So the world works asynchronous. If you look back at those S3 design principles, asynchrony, autonomy, local decision, make decisions on local data, simplicity, controlled, asymmetry, symmetry, simplicity, all of those were distributed systems principles, but we derived them from how the real world works. And if you think about synchrony, synchrony is a simplification. It's just something that makes it easier for us to write our programs. But you know what? Synchrony is an illusion. It's something that we've built over a world that is asynchronous.
Muito interessante, né? É realmente para refletir e mudar um pouco, talvez, o mindset que a gente tem atualmente. Que é normal se pensar nas coisas como síncronas E aqui ele traz essa provocação de que tudo é assíncrono e que o que a gente pensa que é síncrono, na verdade, é uma simplificação, é uma abstração, é uma ilusão. Agora vamos ver aqui o que a vice-presidente de Serverless da AWS falou sobre Serverless First. Bora lá.
With serverless, you're able to automatically scale up and down with demand. It reduces cost with pay-as-you-go usage. You're able to leverage the built-in reliability. And of course, it's easy to use. Inside serverless, we take advantage of economies of scale and we keep innovating to run workloads more efficiently, passing on the savings and reliability to you. It's what we obsess about every single day, with many teams of engineers doing just this as their core job. This is why more and more customers are choosing serverless. Using serverless increases the speed at which applications can be developed, which translates to increased agility and productivity for your organization. Serverless automates high-performance scaling so you can meet the demands of your customers as your business grows. Serverless helps customers achieve the lowest TCO by offering pay-per-use pricing and also reduces the operational overhead so your engineers can focus on high-impact work. And AWS customers using serverless benefit from the built-in inclusion of security best practices. We believe serverless should be your default compute option when building a new application today to help you do the most for your business. And customers agree. Mathem is Sweden's largest online-only grocer. They started using Lambda in 2020. By decoupling services with EventBridge, they're able to ship features in as little as 3 days. Founded in 2017, Utopus aims to accelerate the integration of renewable energy into the power grid by optimizing energy production using analytics and insights. They serve over 235 customers globally. At launch, they started with an on-prem solution in order to process petabytes of data. This didn't scale, so they decided to move to AWS and selected to use fully managed serverless solutions wherever possible. They ended up choosing Fargate and Lambda, and today with Lambda, they're processing over 200 billion signals every day in under 2 hours. As a comparison, that takes over 2 weeks with their former solution. And according to Deloitte, building and running a solution on serverless is 57% cheaper than server-based solutions. These are not exceptions. We hear similar stories from serverless customers all the time. So for many customers, their first decision when it comes to building an application is compute. You can start with EC2 and have all those knobs, or you can go to the completely other end of the spectrum and go with AWS Lambda, where you're focusing just on your application. The layers of abstraction available to you with AWS is very empowering because your teams have the choice and we provide the tools, services, and APIs to help you build your applications. When you're looking to optimize for your time to market and your pace of innovation, we always suggest you start with Lambda because you'll manage as little as possible. Ultimately, when you make technical decisions, you have to consider your existing application portfolio, and you have a few options. You can start fresh and build new applications. This is what many customers start, and it makes sense because you're building with serverless building blocks from the ground up without addressing technical debt. But when it comes to your existing portfolio, you also have a few options. You can reduce the amount of stuff that you're running by retiring systems or adopting fully managed SaaS solutions. Next, you can do a lift and shift migration to AWS, and most customers benefit from doing this quickly to get out of data center management and onto a common environment. But then, when it comes to modernizing, you can re-platform or refactor. When I say re-platform, what I mean is taking a service that you manage and having AWS manage it for you, such as moving to a managed database or going from a self-managed RabbitMQ to an Amazon MQ. Refactoring is where our customers see the biggest transformation. And we see successful customers start by refactoring their most business-critical or customer-facing applications because that's where they'll get the most time to market and TCO benefits. We'll focus most on modernization and building applications today. As a first step, many customers re-platform their applications, especially if they're using a more traditional application architecture. Containerizing applications and running them on ECS Fargate is a great place to start. But modernization doesn't stop here. It usually involves refactoring. A good mental model is we first modernize your mission-critical applications, and then we refactor to higher levels of abstraction so you manage less and can focus on your code and the value that you add. In this case, you'd look to refactor services upstack to AWS Lambda wherever possible, especially if the services are event-driven or face unpredictable demand. And finally, when building greenfield applications, we recommend starting serverless first. How do you make this decision? Where do you start? In this approach, you can think of serverless as maximizing the use of fully managed services in your application architecture. If your application can use Lambda's programming model, that's a good place to start. Some of our most successful customers ask this question: can this service or application run on Lambda? And if it can, that's exactly what they do. This offloads most of the responsibility for operating and managing their applications, so they can focus on higher value added work.
Bem interessante ali a abordagem que a AWS está propondo, né? Então, caso você tenha aplicações no ambiente on-premises e quer migrar, quer fazer o rehost ali para a AWS, ok, então talvez sua opção mais rápida é fazer um replatforming e migrar para um ECS, Fargate, né? E agora, para a utilização de Lambda, que aí já seria, né, um cenário em que a infraestrutura é mais autogerenciada ainda, que é o apontado como ideal, aí exige algum grau de refatoração, né? Então, para aplicações novas, a recomendação já é sempre faça a pergunta: dá para fazer em Lambda? Se sim, então faça. E caso não dê para fazer, porque vai exigir refatoração e isso vai exigir um determinado tempo que você não tem esse time to market, então faça o replatform para um ECS, para um Fargate e tal, e depois você avalia uma possível refatoração. Sempre experimentar ali o serverless primeiro, para depois, caso você tenha, né, a convicção que no seu caso, para o seu contexto, o ideal seria uma solução baseada em servidor, então, ok, você migra para um EKS, por exemplo, mas a AWS tem feito essa recomendação, e não foi a única palestra que falou disso, né? Foram várias, sempre recomendando ali o serverless first, sempre recomendando as soluções com infraestrutura mais gerenciada pela AWS, para que você possa focar os seus engenheiros, o seu time, no código do seu negócio e não no gerenciamento da infraestrutura. Aqui a gente tem uma palestra bem interessante de um dos principal engineers da AWS sobre arquiteturas orientadas a eventos. Vamos conferir.
All right, so let's jump to the other one. And I'll tell you, here's a pattern. We always recommend always go asynchronous when you can. There are times for synchronous. I am not here to tell you use synchronous and you're not a 10x developer, whatever that means, right? There are some times when you need synchronous, but try asynchronous first. When you can use asynchronous, do it. But there's some advantages and disadvantages on that. So let's look at these. So there's a couple of ways of doing asynchronous. The first we're going to talk about is the point-to-point model, or a queue. So what does that look like? So you have a sender, and you have a receiver, much like before, but now you have a queue in the middle of it, right? So you could be sending things into the queue, and then as the receiver's ready, they'll handle that, but this becomes an asynchronous model. What the sender gets, if you're not familiar with this model, what the sender is going to get synchronously, I know we're talking about async, but synchronously is I got your request, thank you very much, we'll get back to you. Okay, it's an acknowledgement of the data, the event, whatever, being sent in. right? Then later, they'll need to either poll or WebSockets or somehow and get the response back if we need to. This is what we often call fire and forget. Excuse me. Sorry, you have to hear me slurp on the mic there. Apologize for that. Okay, so again, it decreases temporal coupling. So we've now, our sender is not broken, okay? If the receiver breaks down, the sender is still working if they need to. It's just going into the queue. And when the receiver is ready, it can grab more. So if it goes down and we bring it back up, we haven't lost those requests. It's resilient to receiver failures, we just talked about, and the receiver controls consumption rate, right? So that's important, okay? It's just a little statement down there. If you think about downstream applications, a lot of times, I've been there, and I won't ask you to raise your hand, but I will mine. When we come in, we work for a company, it's like, hey, we have this legacy system that can handle 3 requests per day. Right? That's probably an exaggeration a little bit, but it can do 3 requests per second. But unfortunately, we're getting 1 billion requests per second. We need you to make that work. All right, well, let's rebuild it. No. No, we want you to make that work. Okay, but let's add more to it. No. So what happens is you need to maintain these legacy systems that can't handle that traffic. So this is where a queue becomes very handy. Because one, you're not invoking that system, you're not running that system for each and every event coming in. You're now able to batch those events, okay? So if they're small and you can run 100 at a time, this gives you a lot of control. So this receiver controls consumption rate helps you protect your downstream system. Okay? We talk about that when people build with serverless all the time is, yeah, serverless scales like crazy, but a lot of times it's talking to our legacy systems that can't handle that. So this is one way to maintain that and control that. Okay, so what happens here is what if one of the events goes bad? What if something breaks? Well, in our send, receive, and our synchronous model, we lost the data, which is always great when someone's making a payment and you take the payment, you process it, and it breaks, and then you go back to the customer and go, hey, we lost your card number. Go ahead and give it to us again. You can trust us. Okay? Your credibility is being shot there, right? So this time, now it's persisted. It's in that queue because we say, okay, do it. Now, if something happens, the queue can be programmed to retry or configured to retry and to handle errors. And, worst case scenario, drop to a dead letter queue so we don't lose the data. It just needs some manual intervention or maybe some other automation that you have. Okay? So you have this resiliency built in automatically by using a queue or a point-to-point model. All right. So another advantage to this here is only one receiver can consume each message. And this kind of, people look at the queue, and the way it works is when, and I'll get more into this later, when a queue is working, what will happen, we'll have several copies of it for redundancy. And then when you grab that, one of your systems grabs those items off the queue, it actually doesn't remove it from the queue, it just hides it. Okay? It hides it until you say, I've processed it. Okay? And then it removes it. And so what happens is it keeps other receivers from grabbing it, so you can make sure that it's, for the most part, we're going to get into that at the end of this, that it's only once, or read at least once. So, okay. Couple disadvantages. Response correlation. What happens if there is a problem and I need to figure out where that goes? So you want to be sure, and again, we'll talk about the item potency a little bit later. Backlog recovery time. If it goes down, sometimes when you got to recover those. But we say disadvantage, maybe it's like just a known thing, because that's better than losing all the data, right? Agreed? Anybody in the room go, I'd just rather lose it. Let's start fresh. Okay, because I want to hire you. So, okay. And finally, fairness in multi-tenant systems. So this can, if you have really hot items grabbing and stuff, you can run into some, making sure that's balanced out. All right. My clicker, hang on a sec, there we go. All right, so the service we use for this, if you're not familiar with this, I've been talking about it, is Amazon SQS. I heavily encourage you to look at this. This is one of the models. We'll talk about a couple other ones. But if you're looking to deal with that, there's FIFO queues where you can keep things in order. And so this is the service that we use. It's a fully managed message queue. It scales almost infinitely. I love that number. How do you scale almost infinitely? So close to infinite, I can't even tell you the numbers. It handles mass amount of traffic. Simple, easy to use, has DLQ as we pointed out, and again, the FIFO like I said.
Aqui foi foco bem grande aqui em filas, né? Então, acho que é ponto super relevante hoje em dia nas arquiteturas orientadas a eventos. A gente conseguir tratar ali de todo o tráfego necessário para que os serviços consigam dar conta de todas as requisições que estão chegando. Então, eu posso ter cenários ali envolvendo sistemas legados que não são tão capazes de processar um volume grande de requisições num curto espaço de tempo. As filas podem ajudar a tratar, e a mesma coisa para os cenários, inclusive, que eu tenho também um serviço mais escalável, enfim. O fato de ter a fila me garante já ter os dados em mãos, caso eu tenha algum erro, algum problema, eu posso tentar reenviar. No pior dos casos, tem a DLQ ali, a Dead Letter Queue, para poder fazer alguma intervenção manual ou colocar algum automatismo em cima para poder posteriormente reprocessar. Então, esse é um conceito interessante aqui de arquiteturas orientadas a eventos, né, que os eventos convém que eles sempre passem por filas para que eu possa garantir um throughput ali das requisições, garantir que eu não tenho que pedir de novo dado para o cliente e que eu vou fazer, né, as tentativas todas ali para garantir que o processamento é feito com sucesso. E aqui nesse trecho a gente tem, né, o conceito aí de orquestração, de coreografia, quais são os princípios básicos de cada um, quais ferramentas, né, Step Function, Event Bridge, e como, né, a gente pode utilizar ambos os conceitos ali em conjunto. Então vamos checar.
There's a couple of words we're going to learn here. That's choreography is the first one. And choreography or choreograph is events between domains using subscriptions. Okay, so domains, how do we break our domains out? We have retail, we have fulfillment. A lot of times I encourage you to look at some of the parameters that you need when you're breaking that out. But let's use these for our examples. So the idea here is, hey, instead of send something out to everybody who needs that, I want you to notify me when an order is created. So I'm going to subscribe to you. Okay? Now, what happens is when an order is created, then they get notified. Order's created, I'm going to send a notification. So that choreography goes between the domains. Okay? So orchestration is we're going to orchestrate a business process within the domain. How do we orchestrate how the events move through the domain and get used? So here's our order. So we have an order up. Retail sends it out. We have an inventory manager. They check. Is it in stock? Yes, it is in stock. If it is, then create an order. All right, I've created an order, and now what I'm going to do is I'm going to generate another event. And the service that we're using in this example is step functions because it's made to orchestrate. It's made to do just that. How many of y'all are familiar with step functions? Okay, part of the room, but not all the room. Okay? I encourage you to go out of the room right now and look up step functions. No, I'm just kidding, don't do that. But I do encourage you as soon as you can to learn about step functions because if you find yourself doing a lot of choreography or orchestration in your function, writing a lot of code to go, if you're this, then this, then this, then this, then this, that's probably not the best way to do it. What you want is a step function, especially when you can just drag and drop and build. And step functions uses SDK to integrate. And we'll jump into that a little bit. So the step functions, it's a workflow. You can build the step functions. They're called state machines. And each step of your workflow is called a state. So what's the data look like as you're moving through? When you execute your state machine, each move from one state to the next is called a state transition. And that's exactly what you're doing. So you're saying, hey, this is my state. Now I need to process some data. Reach out to a Lambda function to process it. Great. Now I need to process some more data. Maybe I'm going to do a translation. I'll talk directly to translate. come back. And so I'm changing the data in the state so as it's moving through. And how you build those is you have a definition, you define it in JSON. You can, CDK is just one example. You can use SAM as well. There's other IAC choices you can use. And we've got like the data science SDK you can use in there. And then you visualize it. And I'm not showing in here, and I'll probably add it later, but the Visual Workflow Studio where you literally just drag and drop boxes and configure, okay? It's just phenomenal, right? You visualize it, and then you execute and monitor, and you can monitor each loop, okay? Step functions help you iterate. It helps you do parallel processing, and you can monitor and watch and evaluate each of that as it's going through. All right, so step function integration types, you have optimized integrations. You can customize to simplify the uses of 17 AWS services, so these are direct integrations. But we also have SDK integrations. This was announced last year, and is a game changer. Okay, what this means is step functions has the AWS SDK built right into it. So rather than you calling a Lambda function that then uses the SDK to talk to a service, step function talks directly to a service. So this takes a lot of code out. When people hear me talk, they're like, do you not like Lambda? I love Lambda. Don't go out of here going, Eric's against Lambda functions. Eric's going to get fired when you say that. Okay? I love Lambda functions when they're appropriate. I'm a big believer in the right tool for the right job. And so if you find yourself, and even Jay Nair, who's charged Lambda, big in Lambda, is known, who's been doing Lambda longer than any of us, he said a Lambda function should be used to transform and not transport. If you're just passing data around, get it out of there, okay? All right, so let's take a look at how these work. So if you think about the request response in a step functions, let's say we get a signal that says, hey, something's in a bucket, we need to do something. We can do a call, a synchronous request, and get the response back. We can then, the next phase will then do a synchronous request to a Lambda function and get it back. Again, there are times when synchronous makes sense. And then finally, you're a jewel. I love you. Thank you very much. All right. All right, and then finally, what happens is we can do an async request to EventBridge saying, we've done this work. We're done, okay? So, synchronous, async. I didn't write any code. I didn't have to do anything. I just simply did it. The only code I did is maybe some custom transformation in the Lambda function. And the nice thing is it works in all these services, including the AWS SDK, so I can talk to so many of these different ones. Another pattern you can use is the wait for task token. Have any of y'all ever been to the Serverless Espresso booth? Oh, good. Anybody planning on going to the Serverless Espresso booth? All right, okay. Yeah, there's a couple of you I know out there had better, okay? So the Serverless Espresso booth, we use this all the time. A step function runs when you order coffee, and what you'll do is you go up, you'll scan a barcode, you do phone number, get a token, you'll enter your menu, and then we'll make it all, and it's all done just the way I'm showing you with these different patterns. I picked up my phone. That's not going to work. All right. So the wait for call, the wait for task token. How this works is we're going to make a call, and we're going to pass a task token. Okay. Step functions do that for you. It sends it out. It says, okay, here it is. Now, we're going to do something. We're going to pass that to the receiver. But what if it fails? Well, then we pass that task token back to a Lambda function that maybe handles the failure and does some code. And then the system ends it. But if it works, then we send it back, and the step function moves on. Now, here's an interesting thing. A standard step function or state machine can wait up to 1 year for interaction. Okay? Wow, 1 year, why would I use that? Well, let's say you have to order some things, you have to manual some things, and you're checking things. Okay, this is done. Okay, now, once that's done, I need to do this. So you see this orchestration power of saying, this has to happen first, then this has to happen, then these 5 things can happen, and now this has to happen once all 5 are done. So you have this ability to wait and say, is it done? And that's how it works. The other pattern we have, I can get my clicker to work there we go, is the run a job sync. This doesn't work with all our services, but some of our services. And how this works is you're actually going to send out, let's say Athena. You're going to send it, and you're going to say to Athena, when you're done, sync with me. let me know. So it lets them know, and then what we can do is we can then do a second one that says get the results. So we start a job. When you're done, let me know. I'll sync that up. Okay, now I'm going to grab the results. I'm going to do something with them, and then I'm going to drop an event into EventBridge to say this is done. Okay, so there's these different patterns that you can look at. This particular one does not work with the SDK, so just keep that in mind. It only works with those particular services. All right, so when you're building applications, when you're building distributed, it's important to understand orchestration and choreography, how to use them together, choreograph between your domains, moving events around. I'm passing around with EventBridge. I'm passing around with, I'm using queues, things like that. Internally, how do I orchestrate? Step functions is your go-to on that, right? So let step functions be that central orchestrator, and then call your Lambda function or your whatever to do that. You can call a step function synchronously or asynchronously by default, but you can also call it synchronously as well. And don't do that if you don't have to, but it's possible.
Bem interessante, né? Esse vídeo aqui vale a pena rever várias vezes para fixar bem o conceito. Acho que é muito comum a gente ver implementações que não são feitas da melhor forma possível, né? Quantos orquestradores você já viu os desenvolvedores que trabalham com você implementar e fazer código para algo que poderia ser feito com Step Function? Então, acho que vale a pena ter esses conceitos bem afinados aqui mesmo. Quando eu tiver que fazer um fluxo, um workflow de processamento, usando vários serviços dentro do meu próprio domínio, então isso é orquestração, e para isso a ferramenta da AWS é o Step Function, né? Faço toda a configuração ali via Step Function, não preciso escrever código para isso, e se eu tiver que transformar algum dado, então eu uso uma lambda. Se eu tiver só que transportar, não preciso da lambda, né? O próprio Step Function pode enviar direto. Agora, se eu terminei de fazer o trabalho que eu tinha que fazer dentro do meu domínio, né? Criei o pedido está criado e acabou o meu trabalho aqui, que é parte do meu domínio, e agora quero disponibilizar essa informação para dar início a uma segunda etapa do meu processo, que é feita em outro domínio, que é a responsabilidade de outro time, então eu tenho um evento, eu tenho aqui uma coreografia, ou seja, eu vou disponibilizar esse evento para que algum outro sistema, de algum outro domínio, de outro time, se inscreva no meu evento e seja notificado, né, que o meu pedido foi criado, por exemplo, e posso utilizar os dados da criação desse evento para dar sequência no processo em outra área, em outro sistema. Agora vamos ver aqui o case da Serverless Presso, né? Contextualizando então. Era um café, uma cafeteria ali que tinha no evento do AWS reInvent, que o sistema, né, que era usado ali para operar a cafeteria foi feito pela AWS seguindo as melhores práticas aí. Então vamos conferir.
So Serverless Espresso is an event-driven coffee ordering app that we built with serverless architecture. We first announced this in reInvent last year, and we really didn't know how popular it would be. We ended up doing 1,900 drinks over the course of the conference, peaking at 71 drinks per hour. Since then, we've been at AWS summits from Paris to Milan, New York, Stockholm, all over the world. We also launched at the EDA Day in London in September, and we've been at GoTo conferences and many others as well. On average, after 26 events, we do about 1,000 drinks per day. So what is the flow? Well, essentially, you walk up to the booth with your cell phone. There's a QR code that changes on a screen behind you. You scan that QR code with your phone, log in with your phone number. That loads the menu, and you place your order. You'll see the order appear on the screens around you, and as the order gets produced, you'll see notifications that go to the screens and also to the phone in your pocket. You also get a cup of coffee at the end. That's the key part of this whole thing. I'll give you a quick walkthrough of the apps, just in case you've not seen it already, but this is the display web app. This is what's on the screen behind the baristas. This shows a dynamic barcode that changes every 5 minutes. It shows the order status of orders in the queue, drinks that are ready. It also responds to global events like the store being opened and closed. The ordering web app, this is what the customer uses with the phone in their pocket. They scan the QR code on the screen, and then once they've logged in, they see a menu where they select the drink that they want, so latte, cappuccino, whatever it might be, whatever modifiers they prefer. Once they hit submit, they get an order number, and then when the barista starts making the drink, that then gets a notification, indicates it's in a pending status, and then finally, when it's ready, they get another notification. There's also a link on this screen that shows you a unique coffee journey, all the steps that your coffee went through in terms of events. And finally, we have this barista web app. Now, the barista only interacts with the tablet. They don't actually talk to the customers coming to the booth. So this tablet gives them a list of all the upcoming orders. It enables them to move the orders into a pending or complete status. They can also take other actions in case they need to cancel the order too. There are a couple of admin actions available too, opening and closing the store. And this connects to a thermal printer. So if you've seen the tickets they're produced, they're coming from this application as well.
Então esse é o desafio, né? Ele mostrou ali um pouco da aplicação, tanto a aplicação web ali que o usuário abre para fazer o pedido, quanto a aplicação que tem no painel e a do barista que faz ali os cafés. Agora vamos ver qual foi a solução que eles implementaram.
So the final architecture looked like this. We had this complete loop going all the way around. You've got your QR scan and orders coming in over these API requests. The processing happens in our step functions workflows, and then the results go back out over this publisher service. And EventBridge choreographs all of this using events flowing between the components. It's very low code, it's very flexible, it's very extensible. There are other microservices I'm not showing here just to keep the slides simple, but they all follow the same model of living on the left-hand side, and they've either got APIs or they've got events they're producing or consuming to be part of this system.
Então segue bem o modelo, né, que a gente viu nos vídeos anteriores, com o Step Function fazendo a orquestração ali entre os serviços. Cada evento eu disponibilizo ali no EventBridge para fazer a coreografia. Então, acho que vale a pena, quem quiser ver na íntegra aqui o vídeo, ele mostra todo o passo a passo que o time foi fazendo, as primeiras versões, os ajustes, até chegar nessa versão final, né? E o interessante que ele comentou é que a solução ficou com muito pouco código, né? Agora vamos ver o preço, quanto que custou aí essa infraestrutura.
So I said at the very beginning, cost was very important to me when we came up with this idea. I really did want to be standing with you here and say, I think I'm proud of what we did, that this is the most cost-effective solution, I think, for running a production coffee bar. Clearly, we could build this by putting it on a laptop and putting it under the desk, but when you want a highly available system that's running in the cloud, we've got multiple events happening all over the world, and really, if this were a production coffee system with multiple stores, we need something that's going to operate this way. So we run about 960 drinks per day as a maximum with the default settings. And so when we ran this at a few events, I went back and looked at our AWS bill and looked at what it cost. And so the big number here is SMS because we're sending text messages to people all over the world. So that cost us about $8, but you'd incur that cost pretty much however you build this because that's just the cost of text messaging. But excluding that cost, when you look at all the other services that are involved, this entire service costs us well under $1 a day. Now, that's actually less than the cost of a single cup of coffee we serve, strangely enough, but fundamentally, when you think about the total cost of ownership and the cost of developer time, the cost of managing code, suddenly this becomes dramatically cheaper than many other solutions. So I'm really happy with how this came out. I think this does actually represent a very cost-effective way to present this.
Como ele comentou aqui, né, o custo maior ali ficou no envio de SMS. Então, se a gente tirar aqueles $7,98 ali, o restante é bem baixo custo, dá menos de $1 por dia. e esse custo ao longo do mês ele é pouco representativo, tendo em conta que o tempo, né, para a construção da solução foi menor, gastou menos com engenheiros para construir e para manter a solução. Então, é uma solução realmente de baixo custo, né, uma eficiência bacana tanto no tempo quanto no custo de manutenção da infraestrutura. Então, conclusões aqui. Né, teve muito foco em alavancar o uso dos produtos já existentes, Lambda, SS, Fargate, Step Functions, Event Bridge, SQS, SNS. Né? Então, não teve grandes lançamentos de produtos serverless no evento. Claro, teve uma série de outros produtos serverless, mas não da vice-presidência de serverless da AWS. Né? A vice-presidência tem trabalhado ali em evoluir os próprios produtos e alavancar o uso em seus clientes. Então, esse foi o foco principal da AWS, muitas palestras voltadas à utilização e casos, né, de uso, e com certeza, acho que, né, o que a gente mais ouviu ali foi a frase mais ouvida ali, né, we use the step function to orchestrate. Então, a utilização do step function para fazer a orquestração de microserviços foi um ponto abordado ali em praticamente todos os cases que foram apresentados nas diversas palestras sobre serverless no evento. Muito obrigado e até mais.